Today we are talking about limits, the last unit for pre-calculus this year. We are going to be talking about evaluating the limits graphically. That's why we are using the graphic calculator today. So we're using the calculator to find limits. Yes, there is a non-calculator way to do that. That's what we're going to be talking about on Wednesday. And to be honest, it's a little bit easier to do it without a calculator because the process of doing it through a calculator can be quite tedious and cumbersome. Okay? So make sure you guys get down your goal. We're going to use your calculator to find limits. But your calculator is a great way to use it to check if you did the algebraic way correctly. So, a little bit of information that you guys need to know, because like I said before, this is the first introduction to calculus, okay? Calculus centers around two fundamental problems, okay? Finding the equation of a tangent line to a graph of a function at a point, okay? First off, what does tangent mean? We talked about that word before. It touches. Well, it touches something. That's what tangent means. So the first fundamental concept is that there's an equation of a line, and this line touches a graph, a function, so like a quadratic, a cubic, whatever, at a particular point. And then the other problem is finding the area between the graph of a function and the x-axis. Okay, so say you had a cubic type function. Okay, calculus would be finding what the area of the shaded region is, that space that's underneath the curve. Okay, that's what these two are the main concepts that calculus centers around. All right, now fundamental to the solution of each of these types of problems is the understanding of the concept of a limit. That's what we're talking about today. Now recall, we've dealt with limits before. You guys remember this notation right here? Yes. It would have been back in the first quarter, maybe second quarter, but I know it was first semester for sure, when we talked about what concept did we deal with that dealt with this?
Set notation.
It's not set notation.
Different exponent.
It deals with the exponent and the graphs.
We did like
It was all those different quadratics. No, it was
Asymptotes. Come on, let's think. What concept have we used limits before? Because this is not the first time that we've used it this year. What concept was it? In behavior. In behavior. Remember, I had you guys do the whole arm thing. When I said, okay, what's the in behavior? We always wrote it in limit notation. So as the function approaches, it usually was a number, or it usually was infinity or negative infinity. It approached
zero sometimes, right?
Infinity, sometimes zero, sometimes another number. So we're going to be looking at that again. We can find the limits, which is basically a number, okay? Or it could be infinity, depending. But basically, we're looking at what's happening to the y values as x gets really close to a particular number or to infinity, okay? And the number that is getting close to is L. It is the limit, okay? So we use our calculator to do this. So we're going to estimate the limit as x approaches 2 of negative 3x plus 1 using a graph. Say again? So, to use your calculator to find this, you can either look at a table of values or you can look at the graph and see what number, or as x gets really close to 2, what is the y value that we're getting close to, okay? So looking at this graph, the closer we get to 2, coming from the left and the right-hand side, coming from this way, coming this way, to approach 2, what number are we getting? What's happening to the y? It's getting really close to what number?
5.
Negative 5. It's getting close right here. That associates with negative 5. So the limit as x approaches 2 of the function would equal 5. So we can look at a graph and see what the limit is. Sometimes depending on, negative 5. Sometimes depending on the graph itself, it may be hard to see what the actual number is. So then that's when we go to using a table, okay? So we're going to go to our calculator. We're going to go up to the y equals, okay? Now everyone should have reset their calculator, so everyone's calculator should look like this, correct? Go to y equals. Y equals is right up here at the top.
Should we change our mode?
You don't have to worry about modes or nothing like that, okay? Everyone at y equals? Let's type in the function. That's negative 3x. Y equals.
Oh.
So -3, then you press the X button. X is located right beside the alpha button. And then +1.
Yes, ma'am.
Now before you click graph, you don't want to click graph because all it's going to do is it's going to show you the picture of what was already on your paper, okay? We want to go look at a table. And more specifically, we want to look at this type of a table because as you can see, the X values are getting closer to 2 from both directions, okay? So to let the calculator know I only want to look at these specific values, what we do is we press the second button. We press the window button. Window is located right beside the Y equals. Now, the TBL start, that's basically where do you want to start your table, okay? If we let this automatically populate, like it's already selected on auto, then we will want to say we want to start at 2, okay?
Mine put 0.
Huh?
Mine said 0.
But you can type it in. That's right, it should say 0 because we reset it. But you can type in whatever number that you want to start with, okay? Now, this triangle TBL basically means how do you want the table to increase? If you want to increase by 1s, then what it's going to do is going to show you, it's going to start at 2, and then it's going to show you 3, 4, 5, 6, increasing by 1s. If you want to increase it by 0.1, then it'll be 2, 2.1, 2.2, 2.3, et cetera, okay? But for us, since we want these specific values for our X variable, what we want to do is we want to go down to independent, and we want to go over and click enter on ask. Because ask allows us to basically type in whatever X values we want to get the corresponding Y value. To be honest, that part
We're
was
allowed to use this on the test.
Yes. Okay? So-
the table value doesn't matter. The one above independent doesn't matter.
No. So, and the only reason why it doesn't matter is because we put it to ask. So it's ask, we're going to tell it what we want it to find. If we left it on auto, then those would matter up there. So is everybody okay? Is everybody on ask? Yes?
Yes.
Okay. So press the second button, and now press the graph button. What it should take you to is a blank table. Now we can type in these values. We had 1.9. So I'm going to do 1.9 and click enter, and it's going to give me the value, the Y value at 1.9, a value that's close to 2. So I'm going to write that in my table. That's -4.7. Then I'm going to type in the next one, 1.99. I get -4.97. And what you basically can do is you can use this table of values to see, okay, what number is the limit approaching as X gets closer to 2. Now, yes, we did use the graph and we were able to see that, but again, you would use something like this if you could not see the graph well. So 1.999, we're getting even closer to 5. Now, when we click 2, and my calculator's about to shut down. I don't know, it doesn't. When it clicks 2, what do you guys get?
-5.
You get -5. Okay, so I'm going to need you guys on this because I think my calculator is about to go into the fritz. Can you guys type in 2.001 and tell me what you get?
-5.003.
What happens when you type in 2.01
-5.0.
and 2.1?
-5.3.
So as you can see, coming from the left-hand side and coming from the right-hand side, we're getting close to the number -5. Now, the reason why I didn't say, okay, well, let's just plug in 2 and see what it is. Because sometimes you'll get an error message. Sometimes you won't be able to plug in the number that it's approaching. Okay? But that's the key. It's approaching this number. So we don't want to know exactly what the number is at 2. We want to see what's happening as it gets closer to 2. So we can see from that it's approaching -5. Same thing we did with in behavior, right? The bigger that X got, it was either approaching positive infinity, negative infinity, 0. It's the same type of concept.
What if an error does show up? What is that supposed to mean?
If an error does show up, then that just means that at 2, it's not defined. But that's okay. We're not concerned about what's the limit as X equals 2. We want it as it's approaching. So if you do get an error message right there, that's fine. You are looking at what's happening the closer you get. So what are these numbers? What are these numbers?
So
What numbers are
you'll
they?
never get an error for those?
No. Well, you can. It just depends on the function. But again, one of these will let you know something. Now, if you get an error message on both sides, then that either means you probably typed something in wrong, or this function is just not a definable function. But you won't get that in this class.
Is it only going to be by point to the hundredth or the thousandth?
You could go smaller if you wanted to. Like you could have done 1.9999, 1.99999, and it'll still show you a number that's getting closer to 2.
We're not figuring out the equation, are we?
You're just figuring out what is that number.
So we're just solving graphs. Or not solving graphs.
Finding out what's happening. So what I want you guys to do is I want you to use your calculator, look at the graph. If you can't quite figure it out what the limit is as x approaches 3, then make your table of values. Okay, you guys have a blank table there. Hopefully you can figure out what values to plug in the closer you get to 3. All right? Figure it out. What's the limit? Don't shout it out. When you're doing this type of function, you have to be careful that when you go to type this into your calculator, you put parentheses around the numerator and around the denominator. If it doesn't, when you type it in, the calculator is going to read do 9 divided by x first, then do x squared minus that, and then minus 3 afterwards. It does an order of operations thing, so it's important that you put the parentheses around it when you go to type it into your calculator. That will make a difference.
Well,
Wait,
that makes more sense.
Yes.
Can you simplify that?
Yes, you can simplify it.
Okay, so it doesn't work.
It will still work. The thing is about the whole simplifying thing is that and that's how you would do it algebraically. So you basically you did it algebraically, which is fine.
I got 13.
So I'm gonna clear this out.
I even did
It's like
parentheses
you
in, so we just
Well, you will get an error around at 3, but we're concerned about what's happening as you
Is it
approach
because it's
3.
Oh, okay.
there's an x minus 2 at the bottom, it's like adding 2 or something?
Uh-huh.
Or a jump?
Oh, I see where it says error.
See, I put mine in differently.
Okay. So I'm gonna go back to my table. Yes, all the things. Oops, forgot. So again, I'm making sure that independent is at ask. When I go to figure out my table, did you guys do 2.9
Yep.
and 2.99
Yep.
and 2.999?
Absolutely.
If I wanted to go one more and do 2 point and do 4 nines, it's just getting me closer to what number? It's getting closer to 6. Now when I actually type in 3, yes, you get an error message. The reason why is because since this is a fraction, if I plug in 3 into the denominator, what do you get? 0. And can you have 0 in the denominator of any fraction?
You get 0 on top of 2.
True, but we'll talk about that on Wednesday. So you're going to get an error message there. But it's still approaching 6. Okay? Did you do 3.001 and 3.01 and 3.1?
Yep.
And you'll see coming from the left side or the right side is approaching 6.
So I have to put parentheses on everything?
If you are dealing with a fraction, yes, you want to make sure that you put those parentheses in there, especially if you're going to use your calculator.
I will say, use that.
But we're not learning algebraically yet, are we?
No, we're going to do algebraically on Wednesday.
When you're writing the table, do you want us just to leave it like
You can put an X, an error, a dash or something. Yes.
I will say how I put it. I just do the alpha, numerator, and denominator, come out and calculator.
Okay, that works too. Alright, now one-sided limits are when you look at only the values of y as x approaches that particular number from one single side. So that means you're only looking at it from the left side or you're only looking at it from the right side. We've talked about this a little bit. Remember, the negative basically means you're approaching it from the left-hand side. The positive means you're approaching it from the right-hand side. Okay, so that's when you're looking at it from one side. You're only looking at those. So it's important that you notice that.
What? That E?
See.
That's a C. Okay? Now the limit of a function as x approaches C exists if and only if both one-sided limits exist and they are equal. Okay? So again, you will only have a function you only have a limit that exists if the left-hand side approaches the same number that the right-hand side approaches. They have to be the same number.
How would they not?
How would they not? If you're dealing with a piecewise function, if you're dealing with, say, a rational function, for example, you know, where it has like the branches where one goes one way and one goes the other way. That could be an example of when it doesn't exist because they approach two different numbers. But the last two examples that we didn't they approach the same number from the left hand and the right hand side? That's why we were able to put it equals 6 or that it equaled -5. If it didn't equal the same number, we would put D and E. Does not exist. Okay? We're going to look at two examples together. And then you guys are going to do a few on your own to make sure that you guys understand the concept. So, it says estimate each one-sided or two-sided limit if it exists. Okay? So we're going to look at this one. We're going to look at it from the left-hand side. We're going to look at it from the right-hand side. And then we're going to look at it collectively together. If this limit exists, then it should be the same number from both sides. Okay? So, let's go into our calculator because I know you guys don't know how to graph the absolute value of 2x over x. Go to our y equals. This is where we type in any of our functions. Now, absolute value. To get that, you go to math, go over to number, and ABS is absolute value. Okay? So math, and then press the right arrow button over to number. Now, when you click this, if your calculator does mine, then that's fine. If your calculator just says ABS with a parenthesis, that's fine too. You just have to close off the parenthesis. So I'm going to type in 2x, and now I have to divide that absolute value by x.
Would you put parentheses or no?
For this, did yours pop up like mine, or did it pop up ABS?
I'll talk to like yours.
Then no, you don't have to worry about parentheses.
I see. Is there a negative in there?
There's no negative. All right, so let's look at the table. We want to look at it as close that we get to 0 from the left-hand side. That's the negative, and then from the right-hand side, okay? So when I go to, I didn't mean to go to graph.
You meant second.
Oh.
But since I did press graph by accident, what number are we approaching as x approaches 0 from the left-hand side? What's the y value?
-2.
It is,
So it's going to be -2 or positive.
it's -2 from the left-hand side. What happens when we approach it from the right-hand side?
Positive.
+2. So this limit is -2. This one is +2. Are they the same?
No.
No. So that means the limit as it approaches it from 0
0.
does not exist. It has to be the same number. One's a positive, one's a negative. Because they are not the same, this limit does not exist.
Are all of them like this in asymptote? Are all of them
Like
like the X on the
absolute.
bottom?
With the x on the bottom, I can't always say that.
Just make it easier by just clicking graph.
So
Well, that's what I'm saying. Sometimes when you click it, you can see the graph and you can see it very easily, especially something like this because they were just two vertical lines. But sometimes it's not easy to see like that. So then that's when you go and you use your table
So
of
on
values.
B, are we gonna do a table one?
This one here, we are actually not going to be able to do a table. We're going to look at the graph for this one. Hand up. Was that you, Brian?
yeah. So the negative in front of the absolute value of 2x doesn't affect it.
No, this negative went with this down here.
Oh.
That was to let you know that it was coming from the left-hand side. And the way that I have to do limits is kind of hard to see it, but normally this is located right underneath the limit, so you wouldn't even have that issue. Like in your homework, it's right underneath it. All right, let's look at this one. Okay, this one we're looking for the limit as x approaches -3. Do me a favor, change these to negative. Change those to negative. Okay, we're looking at 3 different ones, just like before. For this particular function, g of x equals
-2.
-2 and +4. This right here is an example of a piecewise function. We talked about these back in first semester. Okay? Now, you cannot graph piecewise functions in your calculator. You cannot do those. These you would have to know how to graph them by hand. It's very simple. You're graphing 2 equations on one graph.
I thought we only use one.
Say again.
Wouldn't you only use one? Or would you have to use both?
You would want to use both. This is saying g of x equals 4 and g of x equals -2. That's the same thing as saying y equals 4 and y equals -2. Those are the 2 lines that you were graphing. What types of lines do these look like?
What are you gonna hear?
Horizontal.
Horizontal.
Horizontal lines. Horizontal, where y equals 4, is basically a horizontal line that crosses the y-axis at 4, and then y equals -2. That's a horizontal line that crosses the y-axis at -2. Now, more specifically, we have to look here. We are going to graph y equals 4 for everything but -3. So that means that when we're graphing this horizontal line that crosses the y-axis at 4, everything but -3 is going to be included. When we graph y equals -2, it's only defined when x is equal to -3. So what do you think we're going to have in -2?
Closed circle.
A closed circle. Right there. This is the graph of this piecewise function. Yes, it's supposed to be a line, but it's only defined for one point.
Why is there a close circle at -3?
Because that equation of y equals -2 is only defined at one point. So because it's only defined at one point, not like a series of points, that's why it's only that closed circle there. So it's only defined when x equals -3. No, nothing else.
Oh.
So what's the limit as x approaches -3 from the left-hand side? What's happening the closer we get to -3 from the left?
Y is the same, right?
It's approaching
4.
4. So the limit as x approaches -3 from the left-hand side is going to be 4. What's happening as the limit approaches -3 from the right-hand side?
It's approaching 4.
From the right, it's approaching 4. So this is the part that's defined on the graph is getting closer to 4.
We would use the one that includes all the points.
You want to use the part of the graph that shows you coming from the right-hand side. These two are the same, yes? So what's the limit as x approaches -3? Does it exist?
Yes.
And what is the value?
4.
Because it's the same number that's approaching. So not all piecewise functions are going to be does not exist. The first example, example A, that was a piecewise function. It was split up. That one did not exist because it approaches two different numbers from the left and the right-hand side. This one, it is a piecewise function, but it approaches the same number from the left and the right-hand side.
So wait, if that point wasn't there, it wouldn't have changed anything?
At that point, it wasn't even there. It still wouldn't change anything. It still approaches the same number from the left and the right-hand side.
It's
So-
just saying that's where the -3 is.
So for these next 5 examples, you are estimating each limit if it exists. That means that the limit as x approaches the number from the left and as x approaches the number from the right, they have to be the same. That's the only way that you'll actually have an answer as the limit approaches the number, period. Okay? So you got to look at the left-hand side and the right-hand side.
I have a question on that.
You guys, for these 5, remember, it's just like the examples that we just did. Okay? If you can't tell from the graph, then make a table. Okay? And then look, what's happening the closer that you get to that x value that's on your limit. Okay? So when you look at this, you're trying to figure out, okay, what's happening the closer that you get to 4. You need to look from the left-hand side and the right-hand side. So what numbers would that be? If you look at the graph and you can't tell by the graph, then that's when you go to your table. Then you want to plug in numbers that are getting close to 4. If you plug in 1 or 2 or 3, that's fine. Those numbers are getting closer to 4, but you want them to be as close as possible. So that's when you plug in the 3.9 or the 3.99 or even the 3.9999 because that's still getting closer to 4. And then whatever those y values are, the closer that you get to 4, that will tell you your limit as x is approaching 4 from the left-hand side. And then you do the exact same opposite, just like what we did for the first 4 examples. We looked at the table. We looked at the values. The closer that we got to the x value that we were approaching. So then you do the exact same thing, except this time you're coming from the right. What are some numbers that you think you would want to plug in to see the closer that you get?
4.00.
4.01, 4.001. Alright, got
4.1.
4.1, okay? Now 4.1 is getting a little bit further from 4. 4.001. It gets a little closer. You can even plug in 4.0000001. But you're still getting closer to 4. And then whatever these numbers are, whatever number you're approaching, that is going to be your limit as approaching from that particular side.
So we need to use numbers that are closer to 4.
Yes.
And that explains why I got this. Okay.
For 0, so one is directly after.
Okay? So when you guys did this, when you plug this into your calculator, it's just like what we were doing for the other examples. When I go to my table, I want a number that's getting closer to 4. So instead of using 2.9, I'm going to use 3.9 or 3.99. That's 100. That's 10,000. The E is just scientific notation. The calculator can only hold but so many zeros or so many numbers. So it uses scientific notation. This is 1 times 10 to the 6th power. So that's 1 and 6 zeros. If I do 3.999, now that's 10 to the 8th power. It's getting extremely large. And if I continue to plug in these these numbers that are really, really close to 4, it's going to be approaching a positive infinity because all they're going to do is just keep getting bigger and bigger and bigger. 4.1, 4.01. Oh, I did 401 by accident. 4.001. There we go. I'm back to the E thing again. That's 1 with 6 zeros. 4.0001. 1 with 8 zeros. It's going to continue to get bigger and bigger and bigger, approaching what number? Infinity. Are these the same?
Yes.
So the limit as x approaches 4 is going to be infinity. Also, guys, remember I said you could look at the graph. If I looked at the graph, as it approaches from the left-hand side, what do you think is happening after off the screen? It keeps going up. From the right-hand side, it keeps going.
Forever and ever.
So you can look at the graph and figure this out too. You don't always have to make a table. You only make a table if you can't quite see it well.
Oh,
Sure
really?
ones right now.
Yes.
Oh, I just always
That means we can use the graph button, right?
Yeah, so then you just hit regular graph. Like the next one. I'm looking at 0 as x approaches 0 of 1 over x. So I'm going to do 1 divided by x. I'm going to look at the graph first just to see if I can tell what's going on. If I can't, I'll look at the table. Remember, we looked at the graph first, and then we looked at the table. As it approaches from the left-hand side, yeah, mine stops. Do you really think it stops there?
No.
And if you're unsure, what can you do?
Table?
Look at the table. Okay, but either or. What's happening from the right-hand side and the left-hand side? Are they approaching the same number?
No, they're positive, negative.
One's approaching a positive number, one's approaching a negative number. Since they're not the same, it's going to be what? D, N, E. Does not exist. Let's look at the next one. For those who made it this far, did you remember to include your parentheses?
Yes.
Good. So I have x squared minus 4, x minus 3. I'm going to look at the graph first just to see if I can tell what it is before I actually look at my table. What am I approaching? As x approaches what number?
Oh. As in X
X approaches 3. Okay, I can't even see my other graph, my other half of the graph. I'm almost certain that I have to have a right-hand side. I could zoom out if I wanted to. See if I see it over here. If I can't see it, okay, I can see it now. All right. As x approaches 3 from the left-hand side, what's happening? It's approaching what? Negative infinity. As approaching the right-hand side, it's approaching. So the limit, D and E.
What kind of graph is
This was a rational function graph. It was. You remember when we did rational functions back in first quarter? We did obliques, slant asymptotes? That was one of those. I want you guys to do the next two on you. Next two are on you. So, let's look at the last two. I do not know off the top of my head. I'm actually going to have to do this. This is a negative
I might have set up my table.
over x to the fourth.
Oh, you don't need a. Oh, because it's not.
Correct. So I'm going to look at the graph first, see if I can see what's going on. And mine's still in the same setting as it was before, so. Now it looks like it's approaching both a negative number. Real quick, I'm just going to check my table. Okay? I'm looking to see as x approaches 0. So from the left-hand side, that's 0.01. Sorry, that's from the right-hand side. E, that's a negative 2 with 8 zeros, a negative 2 with 12 zeros, and negative 2 with 20 zeros. Looks like I'm approaching negative what? Infinity.
Wait, I thought you had to set go to a table, set it, and then set the number you're approaching.
Now when you're asking, the top part doesn't matter. If you run auto, then yes, it does matter. But if I'm just asking it myself, the settings on the table don't matter.
Oh, okay.
0.01, negative 0.001. Again, negative 2 with 8 zeros, negative 2 with 12 zeros, negative 2 with 16 zeros. That is approaching a, because it's approaching from both sides. And now the last one, cosine of 1 over x. Now with the trig functions, it does matter a little bit. But we reset all of our calculators, correct?
Yes.
So real quick, press the mode button. It's right beside your second button. Were you in radian or were you in degree? Perfect. That's fine. That's fine. That's good. The only time you want to be in degree is if you're dealing with degrees. If there's no degree symbol anywhere in that problem, you leave it in radian. Okay? So when I go to y equals, I'm recording, right? Okay. So that's cosine of 1 cosine 1 over x, close parenthesis. Look at my graph. I'm looking as x approaches, what, 0?
It does a tiny little blip there.
Little blip?
Yeah.
I really can't tell. I mean, besides the fact I zoomed out. Could you guys tell better if I zoomed in?
Yeah, you can see it.
Yeah, it's negative.
There it is.
And my calculator has frozen. So I can't show this one on the video. But what did you guys get?
Negative 1.
Negative 1.
Negative 1?
Yes.
Okay. So if my calculator had acted right, it would have been negative 1 that it would approach from using the graph. But I can also use the table.
Well, all the graphs, like, will there be a problem like they're approaching the same direction? One is like stopping short, and like one is like.
No.
Okay, so if they're generally approaching the same direction, you can tell that they're going in the same direction.
Yeah. It's going to be very rare that it's going to actually stop and not make it all the way. Your calculator may show it's stopping.
Uh-huh.
But if you zoom in a little bit closer, it'll probably just show connecting. It's just a window type thing.
I didn't see it.
Okay? Questions on limits as they approach a number?
No, I think I might have.
So, 3 things that you need to remember. That a limit as x approaches a number does not exist if the value from the left-hand side is different from the value from the right-hand side, one increases or decreases without bound, meaning that it either go into positive infinity or negative infinity. Okay? And the third one, if it oscillates between 2 fixed values. If you're like, Ms. Aronson, what does oscillate mean? Say you're looking at a graph and it's just going back and forth between 2 values. What graphs do we know go between 2 values? Sine and cosine. Okay? So if it asks you to figure out x as it approaches a particular number, like say infinity or something, we know that it just oscillates in between positive 1 and negative 1. So then that would not exist. But these are 3 situations where a limit is not going to exist. Be done with it. All right. So last little bit, limits to infinity. These are already listed. Do realize that as you approach a particular number, as you guys saw in the examples, you can go to positive infinity or negative infinity, okay? And then, yes, there is a certain thing as approaching infinity from the left-hand side, approaching infinity from the right-hand side. That means you're going to infinity from the left and then from the right. Okay? So, look at these ones. It says estimate the limit if x exists as the limit as x approaches infinity of 1 over x. So this time, instead of plugging in numbers like how we did the other one, we plugged in like, 3.9, 3.99, 3.999 to try to figure out as x approaches 4. We're doing infinity. So that means we probably want to plug in what types of numbers you think? 1,000. What's another? 10,000. What's another? Maybe not that many, because calculator can only hold but so many zeros. But yes, 1,000, 10,000, 100,000, because those are numbers that are getting closer to infinity. So when we go to our graph, I forgot my calculator is not working. You can also look at the graph. If it's not looking too, if you're like, oh, I don't want to deal with the table, look at the graph. Like I said, table is only used if you really can't tell.
I don't think it's gonna work.
Nope, it's working. Okay, as x approaches infinity. Now, granted, yes, my graph only shows up to 10. Okay? If I wanted to change the window, I really could. But let's take a look at our table. And let's plug in those super big numbers like 1,000, 10,000. The negative means that instead of making the number bigger, you're making the number smaller. This is going to be approaching what number?
Negative. I would say 0.
0. Yes. 1e to the negative 4 is basically 1 times 10 to the negative 4. That's 0.0000. Sorry, 1. Scientific notation. So it's getting closer and closer and closer to 0. Okay? Let's look at the next one as this approaches negative infinity. Hopefully my calculator can make it without shutting down for the third time. I don't need parentheses here because it's going to do order of operations. I want it to do -3 divided by x squared plus 2. I'm going to look at my graph first, see if I can tell what's happening the closer I get to negative infinity. Okay? The closer I get to negative infinity, we'll be going this way. Now, I don't know about you, but I can't really tell if that's a -2 or a -3. So I'm going to look at my table. I could zoom out if I wanted to, but I'm just going to go to my table. A -1,000. A -10,000. Oh. Looks like it was a 2. So the limit is equal to 2.
Okay, also.
Yep, because that just means that, maybe we plugged in a smaller number that was approaching infinity, like maybe -100. It probably would have given something that was a little, like a decimal or something. Now the last one. Sin x. We should already know what this looks like, right?
That's the way
It's going to oscillate. Oh. If you get something like this, I'm glad I got this. You know good and well it's supposed to be oscillating like a sine curve. What's my issue, you think?
You didn't close the parentheses.
No. Huh?
You're in degrees.
I am degrees.
Why would it do that?
I'm going.
For mine, because mine was like a technical thing, so when I shut it down, it doesn't like reset my calculator. It just basically picks it back up where it left off, which was on degree mode the last time I used it. So now when I go to my graph, now it's looking more like a sine curve.
Because you closed parentheses.
Why does it change it? Well, the default for any calculator is always radian mode. So, because that's how they used to figure out angles and things like that using radians, not degrees. So as it approaches positive infinity, it's going to be doing what?
Oscillate.
Which means that it,
Does not exist.
easy enough. And those are limits, using them graphically. Now me personally, I do not like finding limits graphically. I only use that as a last resort if I can't do it algebraically. So on Wednesday, when we talk about limits algebraically, I'm more likely to do that versus trying to pull up my calculator, type in the graph, look at the graph, and if I can't figure it out, pull up a table. I'm not going to do that. I'm more likely to do it algebraically. But you can't always check your work using a calculator. Yes, you will need a calculator to do your homework tonight because we haven't done it algebraically. There are calculator apps that you can use. You can always use MathWay. Actually type in the function and look at the graph. And even then, you can just kind of pinch zoom to see what's happening as it approaches infinity or what's happening the closer you get to a particular number. Okay? But there you go.